Good morning, everyone. Thank you for joining us for our Understanding LEDs webinar. We want to thank Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support and co-sponsoring our series of free educational trainings that are open to all Northwest utilities and their customers. My name is Lorena, and I will be hosting today's webinar. I will be monitoring our chat discussions throughout the session that you'll see to the right side of your screen. If you have any questions or if we have questions for you, we'll be submitting them through there. Before I introduce the presenter, I want to show you also our webinar is intended to be informal. We want it to be interactive for you. So you'll see right next to your name that you logged in, you have a little raise your hand icon. If at any point you have any question that you want to ask over the phone, let me know. Or at the end of the session, we also have some dedicated time that we'll be asking Mark Whitney questions. You'll also notice on the top of your screen to the left, you'll see this annotating WebEx Tools where you can use a pointer, a highlighter, and whatnot. You'll see it show up. It's, Mark will let you know throughout the session which one to use to interact so he can learn more about you as we go and you can participate as well. I'll mute that. So I'll introduce Mark Whitney. Has been with PGE for for a while now, long time. And for the past 10 years, he's been an active with local Oregon section of the Illumination Engineering Society of North America. Some of you may know it as IESNA, which is a widely recognized as the lighting authority that we go by. Mark has a long history of providing lighting education to professionals and has instructed all levels of lighting courses offered through IESNA and PGE as well for customers and employees. As a lead accredited professional, Mark is also familiar with sustainability issues, particularly issues that relate to lighting. So without further ado, I'll go ahead and pass it over to Mark Whitney.
Thanks, Lorena, and welcome everyone to today's lighting webinar. Thanks also for taking time out of your busy schedules to learn about LEDs and how that knowledge can help you make good lighting upgrade decisions. This webinar, we're going to be using examples for PG customers. However, learning about LEDs will benefit all listeners today. LEDs, or light-emitting diodes, are creating a revolution in lighting because they offer many advantages that other light sources can't provide nearly as well. However, keep in mind that LEDs are not always the best or even the most efficient option now for many applications. So this webinar will help you decide which LEDs are ready for you now and which ones in the near future. So up on the screen is today's agenda. Throughout the presentation, I'll be focusing on saving energy, saving money, and providing better quality lighting through a lighting upgrade project. The goal today is to supply you with information about LED lighting and energy efficiency that's going to make a difference at your place of business. So we invite your active participation today and plan to leave some time at the end to answer your questions. So here's the time to practice your annotation tools. I'll ask you to, as you look at this list, indicate with an arrow or a line or pointer which one of these key learning objectives is most important to you today. So this webinar is not going to go in depth on how LEDs work. We have a half-day seminar that does that, but I will go over some basics. Throughout the presentation, I'll talk about familiar current lighting technologies and what the LED alternatives are. The focus is going to be on retrofit, but new construction applies also. Some LED applications make sense right now, while some are going to need to mature or become less expensive. At the end, I'll go over how you can get help with your lighting upgrade project. So what's all the fuss about LEDs? You're hearing a lot about LEDs. There's a wide range of quality and performance, so you need to be informed in order to make good choices. So the pictures you're seeing represent some recent award winners. Some are from the next generation luminaires, which focuses on commercial and industrial type fixtures, while the lighting for tomorrow is more residential. So check out their websites for winner profiles and more pictures. And by the way, Next Generation Luminaires just announced winners of their outdoor LED competition last week, and you can see those on the website. This graph illustrates the breakdown of various lighting technologies based on energy consumption. I put this up here just to give you a perspective of where different light sources are currently being used. Over here, residential, you can see it's dominated by incandescent lamps, which includes halogen. The commercial sector uses mostly linear fluorescent, which is dominated by T8s right now. The industrial and the outdoor use a lot of HID, that stands for high intensity discharge, and this is high pressure sodium and metal halide primarily. Now you're going to have to look closely, but at this lower right hand column at the bottom, you see this yellow bar, and that represents LED. And back in 2010, that represented less than 1% of the total market. While that's increased a little, it's still a very small amount of the market share and energy consumption for lighting. This graph illustrates the dramatic growth that is expected from LEDs in the not too distant future. And one of the things I wanted to point out is that most of the growth is expected to come from the replacement of existing incumbent technologies. So what is an LED? LEDs are a form of solid-state lighting. They are a semiconductor device that generates light. In many ways, an LED is the opposite of a photovoltaic solar cell. So instead of turning light into electricity, LEDs turn electricity into light. So hopefully that's a good way to think about how LEDs work. So light is produced through the movement of electrons through a semiconductor material. In this last picture in the bottom, you'll notice that many components are needed to create a practical LED light source. For instance, you're going to need something to attach the LED to. You're going to need some electrical connections. You're going to need a lens. You're going to need some kind of a thermal heat sink. So a lot of things to make an LED work. One thing to keep in mind is that LED actually has a lot in common with the fast-paced high-tech industry. And this clashes with the relatively slow-paced lighting industry. And because of this, there's going to be a lot of culture adjustments in the future. So how do LEDs make white light? Well, there's two main ways that you can do this. The most common and least expensive way is on the left, and that is to take a blue or a violet LED and then coat it with phosphor similar to the ones used for fluorescent lighting. The other method you see on the right combines red, green, and blue LEDs, and sometimes some other colors. By varying the intensity of each LED, you can not only create various shades of white, but also any other color. And this method is primarily used in theatrical lighting. Why use LEDs? Probably number one reason is because they produce light efficiently. On this chart, you can see the history of various light sources and the improvements that they've made over time. But if you look over here with white light LEDs, they didn't even show up until around the year 2000. And the growth and the advancements with the LED has been very dramatic. Another reason is that LEDs can have a long lamp life, 100,000 hours or more for some types. One of their strengths is that they're directional in nature, and this works very well for some applications, but others, this characteristic makes the lamp more challenging. They're small, but because they all need some type of a heat sink, some fixtures actually end up being very big. Dimmability is a strong feature of LEDs. However, compatibility with existing dimmers is often an issue. Unlike fluorescent and HID, LEDs don't contain any mercury. They don't have ultraviolet that can be harmful to people and products. And they don't have infrared heat, but they still have conductive heat. This chart illustrates the historical and predictive trend of LED light put and cost. You can see that costs are going down while light output is going up at the same time. A predictor of this relationship is called Haigh's law. It's similar to Moore's law for computer chips. Haigh's law states that the cost per lumen falls by a factor of 10 every decade, and the amount of light generated per LED package increases by a factor of 10. And so far, this law is held very true. As a new light source, LEDs have several challenges and issues that I want to go over with you this morning. All LEDs produce heat that needs to be conducted away from the source in order to operate efficiently and also to last longer. Each of these bulbs that you see in the bottom use different methods. This light bulb from a company called Switch has a unique liquid-cooled method for getting rid of heat. Soleus actually has a tiny little fan inside their lamps to cool them off. GE and most other companies use some kind of a thermal fin to conduct the heat away from that junction where the light is being produced. Lamp life is different for LEDs, where most other lighting sources are rated at a 50% failure rate. LEDs are rated for failure at a 30% light loss. So it's really good. There's really good lumens per watt now, but it's getting better. 60 to 90 is pretty typical, but the potential is higher than 200 lumens per watt, maybe 5 to 10 years down the road. They need to be less expensive, which is one of the current barriers. More consistent color and performance, and better performance is needed, especially for demanding applications. But for most applications, the color is pretty good. Already mentioned dimming issues. Compatibility with existing dimmers can be an issue. How to specify? We're looking at a whole new lighting world. The Department of Energy is taking the lead in developing and promoting energy-efficient solid-state lighting. The website listed here has lots of info, and I purposely made it very big, so I want everyone to write this one down and make this your first stop for learning more about LEDs. Over here, research and development. These activities are identifying ways to make LEDs more efficient and less expensive. They also promote making as many components as possible right here in the good old United States. Demonstration projects are very helpful in finding out how LEDs perform in the real world. Any new technology needs to be tested in order to gain confidence in their performance claim. Standards for testing are critical for consumer confidence, and I'll go over a couple of those today. Product competitions have challenged manufacturers to create better market-ready products, and end users need help and confidence when choosing to buy LED products. Good and useful labeling, along with educational resources, is available. The Lighting Facts label is similar to a nutrition label. It gives you important information about an LED lamp. Light output is measured in lumens. Watts is a measure of the energy required to light the LED lamp. The lower the wattage, the less energy is used. You put these together and you get lumens per watt, and this indicates efficiency. The higher the number, the more efficient the product. The more correct term is known as efficacy. Color temperature measures light color of the light source. Cool colors have higher color Kelvin temperatures, 3600 to 5500 K. Warm colors have lower color temperatures, 2700 to 3000 K. Cool white light is usually better for visual tasks, while warm light is usually better for living spaces because it casts a more appealing light on skin and clothing. The color rendering index is a 0 to 100 scale, and this indicates the effect of the lamp's light spectrum on the color appearance of objects. The higher the number, the truer the appearance of the light on objects. Incandescent lighting is near 100 on this scale. Most applications should have a CRI rating of at least 70, and for color critical applications like retail, 80 CRI or higher is needed. And even 90 plus CRI is available. Caliper is like the Consumer Reports of solid state lighting. LED products are obtained anonymously and then they're thoroughly tested. And then they publish periodic reports online for everyone to take a look at. They start out with a summary report that gives you an overview, and then it's followed up with a detailed report, and that gives you more product-specific information. Once again, here's the website to find this information. Don't worry, there won't be a test on this slide, but I did want to talk about some standards for solid-state lighting. One of them, the one you might hear the most about, is called LM79. And what this does, it provides a standard testing method for LED products. But keep in mind that just because a product was tested according to this standard, it doesn't mean it's a good product. It only means that it was evaluated properly. LM80 provides a method for measuring the lumen depreciation of LEDs. Remember, LEDs lose light over time. And finally, TM21 provides a method that allows you to take the information that you get from LM80 data and then make a projection about the lumen maintenance of the LED light source. So these standards and others are very helpful and should be used as a starting point for evaluating LEDs. To qualify for incentives in most parts of the country, you need to be using an LED product that's on some approved list. So all of these on this page can be accessed through the Lighting Design Lab website at the top. There's two national LED lists, the Energy Star and the Design Lights Consortium. The Lighting Design Lab lists, on the other hand, they include LED products that haven't yet made either of the national lists. And that's usually because the time-consuming lifetime testing has not been completed yet. However, the ones on the Lighting Design Lab list are expected to qualify for either the national list. So in this way, the Lighting Design Lab is a temporary list, and LED products can only remain on their list for a maximum of 1 year. The Energy Trust of Oregon recognizes any LED lamp or fixture that is included on any of these three lists for the purpose of qualifying for cash incentives. Again, the important thing here is to find an approved LED product, go to this website. Before we go any further, I want to go over some lighting terms that help us describe lamps. And this involves a little math. When you see a description for a lamp, you'll see a letter. That designates the relative shape of the lamp, where the number designates the maximum diameter in eighths of an inch. So for example, this T8 lamp at the bottom, the T stands for tubular, and the 8 stands for 8/8. This is easy math, 1 inch. The other ones get a little more complicated. You have a reflector lamp. That's what the R stands for, 30/8 of an inch. A globe. This one's also 30/8 of an inch, or 3 3/4 inch, if you don't have your calculators handy. Here's a candle type lamp, 10/8. And here's what's called a parabolic aluminized reflector, and it's 38/8 of an inch. An interesting trend with directional LED lamps is often the letters have lost their meaning. For example, this LED PAR lamp no longer has a parabolic aluminized reflector in it at all. However, it retains the letter designation simply because it's familiar to customers and end users. To help illustrate the many benefits of LEDs, I want to start out with the familiar incandescent light bulb. This is one of the main replacement targets for LEDs. In fact, new lighting laws will virtually eliminate the most common ones, And that started with the 100-watt light bulb last year and the 75-watt bulb this year. Generally speaking, you're going to have 3 replacement options for these bulbs that are going away. One is to look at your choices is good, better, and best. Good is your energy saving incandescent. They typically save 25 to 30% over the incandescent they're replacing. CFLs are better. They save usually around 75%. And the best is LED, which saves 75% or more. Now we can go over just a few of the performance features to help you compare. One of the ones we've kind of talked about is lamp life. As you can see, the incandescents, short lamp life, CFLs are better. LEDs, very long lifetime. First cost is usually lowest for the incandescents, a little higher for the CFLs, and right now the LEDs first cost is quite high. We already talked about energy savings. Dimming is a key issue. Incandescents, as we all know, dim really well. CFLs, for the most part, don't. And LEDs, sometimes yes, sometimes no. Color quality, the incandescents set a high standard for CRI. Considered to be excellent. CFLs, not quite as good. LEDs are from very good to excellent. So you need to do your homework. Make a choice based on your application, hours of operation, and the features that are important to you. And this applies not only to light bulbs, but other LED lamps and fixtures as well. So here's some energy-saving bulb examples from GE, Philips, and Sylvania, considered the big 3 of lamps. The energy-saving incandescents still make sense for applications that have low hours of operation and where you want dimming and the warm color temperature shift that incandescents can give you. CFLs are going to be for applications with longer hours of operation and no need for dimming and infrequent switching. LEDs are best for applications with very long hours of operation and where bulb replacement is expensive or difficult. LEDs also can dim, and they don't mind frequent switching. Remember that one of the strengths of LEDs is that they're very directional. This makes it a challenge to imitate the omnidirectional light output of an ordinary incandescent light bulb. So this means you need to pay attention when buying an LED light bulb replacement. The bulbs on the left and the one on the right do a pretty good job of replicating the ordinary light bulb, but the one in the middle distributes much more light in one direction. So this would make a really poor choice for a table lamp where you would want most of the light to shine down for reading. However, if you took this lamp, it might work great if it was installed base up where most of that light was shining down, perhaps in a task light. I actually have a task light at home where I've done this very thing. So keep this in mind when you select LED light bulbs. Here we're going to talk about efficacy and efficiency. Efficacy is a term we learned earlier. It indicates the lumens per watt of a light source. In this example, we have a CFL with an efficacy of 60 lumens per watt. However, the number of lumens that are delivered to the room is decreased because you need to install it in this CFL in some type of a fixture. So in this example, the CFL is installed in a downlight that is only 58% efficient, and this is actually very common. So you're losing a lot of light bouncing around in that fixture. So the delivered lumens now is only 35 lumens per watt instead of the original 60 lumens per watt of the bare lamp. Now an LED downlight fixture or a retrofit kit, in this example, it's tested in a manner that rates lumens per watt for the entire fixture, as opposed to the CFL where just the lamp is tested. So this is why the LED downlight is rated as 100% efficient. So all 70 lumens can be expected to be delivered into the room. So it's very important to know this difference when you compare LEDs with other light sources. So in this example, the LED downlight is twice as efficient as the CFL downlight and would save 50%, only 13 watts instead of 26 watts. Now, let's put an incandescent in this fixture. So the savings would be much higher, and this application would actually be eligible for an Energy Trust cash incentive. So replacing an existing CFL downlight would need to be evaluated for a custom incentive instead of a prescriptive, like an incandescent bulb. So the important thing is, by any measure, LED makes an excellent choice for this type of application. Let's turn our attention now to track lights. We're going to find out the many reasons why this is one of the very best LED applications right now. Keep in mind, when I use the term halogen, I'm referring to a more efficient type of incandescent lamp. So many of you know that the common light bulb is being phased out, but most don't realize that the most common reflector type lamps listed here are also being phased out. What this means is that very soon you won't be able to purchase the most common types of incandescent or halogen reflector lamps. Instead, you're going to need to buy the more efficient halogen infrared versions of these types. But this type is going to be more expensive, but they will pay for themselves over time. However, and the main point of all this is that a much better alternative is to upgrade to LED directional replacement lamps. So let's find out why. So until just recently, there just hasn't been an acceptable alternative for halogen reflector lamps for track lighting. CFLs have a poor beam pattern. They just don't have a good enough color quality. Ceramic metal halide lamps were tried, and they've been a reasonable choice, but they have some shortcomings in light quality and lamp life. So the screw-in LED replacement directional lamps, they have improved to the point where they're now an excellent alternative to halogen. They have great energy savings, long lamp life, excellent color quality, and this is what makes them a compelling choice. But keep in mind that even if they didn't save any energy, it would be much cheaper to buy one LED lamp replacement that lasts, say, 35,000 hours or more instead of 10 halogens over that time. And think about the hassle of changing out those 10 lamps. However, LEDs do save a lot of energy, and they even qualify for generous cash incentives through Energy Trust of Oregon, which oftentimes covers up to half the LED lamp cost. So once you decide you want to go with LED replacement lamps, it's a good time to evaluate your options, since you're going to be living with this choice for about 10 years or so. In this way, buying an LED is actually a lot more like choosing an appliance than it is a typical light bulb. So it's best to get a few samples, try them out. Directional lamps are commonly made with beam angles from about 10 degrees up to around 60 degrees or so. 25 and 40 degrees are two common LED choices that you'll see right now. So the beam angle that you choose depends on part on the mounting height and the distance of the objects, distance to the objects that you want illuminated. The center beam candle power will also help determine how brightly those objects will be illuminated. The smaller the beam angle, the more intense the center beam power will be. When you test out your sample, look for smooth, tapered edges, no dark spots, streaking, no noticeable color variations within the beam of light. We're going to talk a little bit about the challenges that smaller LED lamps have. The larger PAR 38 and PAR 30 lamps, they have an easier time dissipating heat because of their larger size, but it becomes much more difficult to manage that heat with smaller lamps like MR16s, PAR 16s, and the candelabra style bulbs. Currently, you can easily find LED MR16s to replace up to 35 watt halogen MR16s, but it's more challenging to find ones to replace 50 watt halogens, but more are coming to market. So I'm going to ask you to use your annotation tools here. So some companies, they cheat a little bit by making their MR16 slightly bigger than the standard MR16. So if you can find out the guilty offenders from this lineup, go ahead and point those out. So it might be okay if the LED lamp sticks out a little bit from some fixtures, but they may not fit in others. Again, you need to try out any LED lamp before you buy a large quantity. So here's the two offenders, the two guys on the left. They're too tall. Okay, thanks everybody. Most of the larger power lamps come with Edison screw bases, like this, very common. Many of the smaller candle-style bulbs come with a smaller base. And there are adapter sockets available if you need them. And these operate at 120 volts AC. MR16s are typically low voltage. They're going to have a base that looks like this. It's 5.3 millimeters apart. They're usually 12 to 24 volts, usually 12 volts. Some PAR 16s and PAR 20s have a push and turn GU10 base, and it operates at 120 volts AC. Others might have a standard Edison base. This illustrates again that you need to know what kind of lamp you're replacing so that you can get the correct LED replacement. It's not that hard, you just have to do your homework and pay attention. So in summary, LED directional replacement lamps and LED downlights are examples of upgrade options that make sense right now and qualify for great prescriptive energy trust cash incentives. We're going to switch gears at this point to compare LED with some other incumbent lighting technologies and applications. So some people are in a big hurry to switch to LEDs. However, it's important to know that linear fluorescent, for instance, right now works really well. So because of that, LED needs to be about 40% better in order to be a mainstream competitor. Replacing linear fluorescent with LED is only cost effective for a few applications right now, especially those with long hours of operation and those that are in cold environments. But that's changing fast, and we're going to go over some of the key issues you need to be aware of in determining when to go with LED over linear fluorescent. So let's go. So cost is a big issue. LED prices are coming down, but they're still somewhat expensive. We talked a little bit about lamp life. Fluorescent is rated at 50% lamp failure. 50,000 hours is not uncommon for fluorescent tubes. There's even a new 84,000 hour lamp from Sylvania that just came out. LED, 75,000 plus hours is not unusual, and even up to 100,000 is possible. Lumens per watt. Again, we measure fluorescent and LED differently. You can have a 100 lumen per watt fluorescent tube, but you're only going to get 85 lumens per watt out of the fixture. The LED fixture, you can get those that have 100 lumens per watt out of the fixture. So they're 10 to 20% better than fluorescent as far as lumens per watt. Fluorescent is a proven workhorse, where LED, while it's promising, it still carries some amount of risk. For controls, frequent switching is an issue for fluorescent. It can shorten the lamp life dramatically. LED doesn't mind frequent switching. Fluorescent is less efficient when it's dimmed, where LED gets more efficient. Okay, so let's look at some applications where linear fluorescent is commonly used, and we'll look at the LED alternatives. So the recessed troffer that you see here is the most common fluorescent fixture, and this is a big target for LED. The prismatic lens version is the most widely used, and it's also the least expensive. So notice the high vertical illumination on the walls. So this type of illumination can be challenging for LED to attain. Remember, LEDs are very directional. The parabolic recessed troffer was originally designed to help eliminate glare on computer screens and is considered by most to be a more modern fixture type. However, glare on computer screens is an issue that has mostly gone away because of flat screen displays. Much bigger issue is the exposed bare lamps and the overhead glare that bothers many people with this type of fixture. Notice here the dark upper walls that creates a cave effect because of the sharp cutoff of the parabolic louvers. Now, retrofitting these parabolics with LED T8 lamps is a tempting option, but can make this cave effect even worse, cause more glare, and also give the fixture an unnatural appearance. And we'll examine LED T8s more closely in the next slide. So many owners and facility managers have been approached by LED T8 salesmen, often many times. So this must be a great LED retrofit option, right? Well, not necessarily. One of them has to do with light output. This chart shows that most T8 lamps, most fluorescent T8 lamps have twice the light output of the LED T8s. Now, the LED T8s in most recent testing are getting better, but keep in mind that most of your LED T8s are going to have less light output. The light distribution, these parabolics, for instance, in this cutaway, the fluorescent T8 gives light off in all directions, and the fixture was designed for this. The LED T8, the light comes out of the bottom half, either like this or maybe even a little bit more pronounced. So this improves fixture efficiency, but it changes the original light distribution of the fixture. Here's the fluorescent distribution, and here's the LED distribution. It's less and it's different. Cost, fluorescent tubes cost about $5, LED T8s $50 or more. While you can get UL approval for the lamps, LED T8 lamps, there are still retrofit installation issues. Keep in mind that you may or may not bypass the existing fluorescent ballast. So this future lamp replacement is also a safety issue. What if you accidentally reinstall a fluorescent T8 someday? So a warning label would be a good idea if you went with LED T8s. All fluorescent lamps rated for a certain color temperature look pretty much alike. LED T8s may have inconsistent color, and that may shift over time. And this is important whenever lamps of any kind are close together, as they are in a parabolic fixture with exposed lamps. And when DOE Caliper program first tested LED T8s, a lot of them failed during the testing procedure. However, they've gotten better, but keep in mind fluorescent T8s are much more reliable. So a much better approach than LED T8s is using LED light bars. These attach directly to the metal fixture housing, and this is good because it provides a natural heat sink. So in retrofitting, the existing fluorescent lamps, lamp holders, and ballast are removed. Next, you install the light bars along with an LED driver. And a driver is similar to a fluorescent ballast, and that is necessary to convert the AC power to DC and operate the LEDs properly. So this is the least expensive LED troffer upgrade option, about $70 to $80, and often cheaper than LED T8s. So you can simply keep the existing lens like this picture shows, but keep in mind that this may not provide the best optics or appearance. A much better approach when using light bars is to use a kit. And this comes with a new, modern, more efficient lens. So this one from Lithonia has a lens that matches their popular fluorescent fixtures like the RT5. From below, it's hard to tell which is which, so you can mix and match LED with fluorescent if you wanted to. There are a lot of companies that make this type of kit with many lens options available. So these kits cost from $100 to $150 and can be very easy to install. Lumens per watt of 90 or higher is very common. And new LED fixtures can also use this type of light bar. So here's a couple examples of new LED troffers with different illumination approaches. Fine Light and others use mid-power LED light engines that are similar to the ones used to backlight flat screen HD TVs. Cree has chosen to mount an indirect reflecting LEDs on top of a decorative room side heatsink strip. Easy for me to say. These fixtures are commonly available. Both these fixtures, all these LED fixtures, are available in 1x4s, 2x4s, and 2x2s, with the 2x2s seeming to be the most popular one, and they seem to offer the most uniform light distribution in all directions. Most of the LED troffers are less than $200 compared to comparable new fluorescent fixtures that are around $100 to $150, to give you some perspective. This is a type of fixture that's often used in lobbies and high-end office spaces. It's chosen because it has good looks, minimizes glare. However, it's expensive, inefficient, and difficult to maintain. This is if you like this type of fixture, this might be a place to start with LED. So you can get ones that look similar to that recessed indirect or basket fixtures, but it's a much better performer. I want to take a moment to let you know about an exciting option that works really well with LEDs. For very little extra cost, you can get LED fixtures that can change their color temperature either manually, like with this controller up on the right, or automatically through a central control system. So you can adjust from warm color temperature to cooler color temperatures. If you want to look at some of the award-winning troffers and desk lamps at this Plan LED website, color temperature changing fixtures can have very positive benefits for your mood, health, and visual acuity. To find out more, check out the Human-Centric Lighting website. Also note that PG is planning a half-day seminar on human-centric lighting in September on the 24th and 25th. Indirect fixtures are popular for their low glare and even illumination, but there really aren't very many comparable LED versions yet. So one product that has some potential is this edge-lit illumination suspended fixture from GE. The fixture is translucent when it's off, and this minimizes the visual impact of the fixture when there's enough daylight in the room for the fixture to be off. So I want to bring up the fluorescent wrap fixture. It's used everywhere it should, and a lot of places it shouldn't, but it's a common general use fixture, and it's also inexpensive. So wrap fixtures, they normally have a prismatic lens, and it wraps around the sides and bottom of the fixture. Has a very wide and even light distribution, and it's a general use fixture that's often surface mounted, but it can also be pendant mounted. So here's an example of an LED version. I don't know the cost of this fixture, but I'm sure that it's going to need to be less expensive in order to compete with the common fluorescent wrap fixture. So let's talk now about some applications with high ceilings. HID stands for high intensity discharge, and that refers to mercury vapor, metal halide, high pressure sodium. So this has a narrow beam of light and is meant to be mounted 20 feet or higher. The low bay fixture, on the other hand, has a much wider beam of light for lower ceiling applications. So both of these fixtures are currently being replaced with fluorescent fixtures, and they often save 50%. And it's also common to attach an occupancy sensor to each fixture for additional savings. So because of this advantage, LED high bays need to be much better performers in order to compete. As you can see from these pictures, LED high bays come in many shapes and sizes. And because fluorescent works well in most applications, it's going to take a while for LED high bays to become a mainstream alternative. So the performance is good, but the fixtures right now are at least twice as expensive as fluorescent, often much more than that. So this makes it difficult for LED high bays to be a cost-effective alternative. So LED fixtures work great in cold environments because they work well. It's easier to get rid of the heat. You can also put occupancy sensors and do very frequent switching. In fact, you can use this type of high bay with a sensor in frozen storage warehouses where they typically need to be on all the time. So now you can turn them off most of the time, and you can actually save 90% or more over high-pressure sodium in frozen storage warehouses. Great application. And then it's qualifying for Energy Trust incentives. So because of limited time, I'm not going to go over outdoor LED fixtures in detail. But keep in mind, some are cost-effective now and some are not. Again, the high cost of the fixture is the main obstacle. Applications you might want to consider are gas station canopies, parking garages, wall packs, and parking lots. So some people are choosing induction lighting for these applications, but I feel it's better to wait for LED prices to come down in the very near future rather than go with a short-term solution like induction. In general, LED outdoor lighting provides more even light distribution. And here you can see much better color temperature, long lamp life, energy savings of 50% or more for all these applications is very common. And they work really well with controls. PG is just beginning the process of changing out many of our street lights to LEDs starting next month. Also, note that PG is going to be hosting a half-day seminar on outdoor lighting on September 26th, and we'll go over these applications in much more detail. In the future, I believe that the majority of lighting applications are going to use an LED light source, but for now, there are still other good choices. So here's a list of issues you might consider. And if you want to use your annotation tool now, you can mark one of these that is important to you. Ambient temperature is important. Lamp life, we talked about that. I think yeah, hours of operation is one of the most critical. The light distribution, we talked about that. We talked about controls. Maintenance is a very big issue with LED and comparing those with other sources. Aesthetics, some people like them, some people don't. But at the very bottom, I think is the most important. It's important to test drive your fixture. Do a mock-up, take a look at them, run it through its paces. This is the best way to evaluate how your fixture is going to perform. Energy Trust of Oregon cash incentives can provide the extra money that you may need to make your LED project work for you financially. Remember, you need to use approved LED products. Prescriptive cash incentives are available for, and we'll go over some of these, LED downlights, talked about those, either new fixtures or kits. You can get $30 per fixture for these. One thing we didn't talk about was LED refrigerated case lights. You can get $20 per linear foot of lamp length. And this is an excellent application. LED directional lamps, I want to harp this again. Very excellent application, $15 to $25 per lamp from Energy Trust. New this year are incentives for outdoor marquee and cabinet signs. You can get $5 per linear foot of lamp length. There's also custom incentives for LEDs not on the prescriptive list, but remember, you have to use approved products and meet all other program criteria. The incentive is up to 35% of the install cost. So PG and Energy Trust, we're here to help you with your energy efficiency projects at your place of business. So either go to the PG website or give us a call and you can receive a free energy efficiency consultation. Commercial customers should contact Paula Conway. Industrial customers can contact John Maloney. Well, I'm going to take a deep breath. I know that was a lot of material in a short amount of time. I hope you found most of it useful, and most importantly, you'll apply your knowledge by undertaking a lighting upgrade project, maybe even one that uses LEDs. So now I want to turn over the remainder of the presentation to Lorena for some additional information and to take your questions. Lorena?
Thank you, Mark. And again, as a reminder, we will be sending the PDF of the materials and the recording of the session to everyone so you can reference. So make sure if you shared your login or you didn't log in with your full name that you chat me your full name and email or other emails of those people who are joining you today so that we can send that to everyone. And that'll happen within a couple days. So before we go into the question and answer portion, I did want to call your attention to the right side of your screen. You should see a poll that came up, and that's just a quick survey. If you can take a few minutes to fill out, we do appreciate everyone's feedback, and this is how we find out what other things we can offer for you, and then also questions or things that we can follow up with. So please do take a couple minutes to take a look at, to fill out the survey and suggest any other recommendations. We're always looking for ways to improve. So Mark, the first question that came through, do you know if PGE sees program incentives levels changing in the future, and what criteria, based on your experience, will be used to determine those changes?
Well, first off, while PGE customers get incentives, the Energy Trust is the organization that actually has the incentives and comes up and designs the incentives. I don't see incentives for LEDs getting higher. One reason is because the cost of LEDs is going down. So the current incentives were gauged based on the prices of LEDs at the time, and as they get cheaper, the incentives probably will go a little bit lower to keep that same percentage of incentive in order to help move the market. So I don't see incentives getting any higher than they are now, but the biggest change is going to be the price of LED products.
And that goes as well with another question that came through. Do you see the LED products becoming cheaper as new ones are being developed?
We're definitely seeing prices trending down. It's a lot like, as I mentioned at the beginning, LED lighting is a lot like the semiconductor world. I know when computers first came out, it seemed like any computer was $2,000. They got better, but they're always $2,000. And then they started getting cheaper, and quite a bit cheaper. And I think you're going to see that same trend with LEDs. Again, the DOE holds workshops throughout the year. They offer research grants and other incentives for squeezing out costs at every phase of manufacturing LEDs and the supply chain and the delivery. So all this, and there's a lot of steps in making an LED. So any improvement, small or big, is going to make a difference in the price of LEDs. And with incentives for LEDs, it's like the chicken and the egg. What comes first? You need incentives in order to have people try it, and you need a lot of people trying it in order for the cost of the product to come down. So we're seeing that happen right now.
Great, thanks, Mark. Where do you see, where are adapters commonly available?
You can get those adapters most any home improvement store or any electrical supply house. It's pretty easy to get if you need that.
Okay. I think this is a question that a lot of people wonder, is now a good time to get LEDs, or should we consider waiting for more testing or others to try first? Like, where are we with that level? We've heard that things change every month.
That is a very good question, and something everybody would like to have a really clear answer to. It's hard to say when to jump in. Again, it's a lot like when computers kept improving, or more recently with cell phones that kept getting better. When do you there's always going to be a better one down the road. So if you keep waiting, you'll never get one. So at some point, you got to decide to jump in. And you want to jump in on those LED applications that make the most sense. Anything that replaces incandescent is something you definitely want to jump in on. Ones that replace linear fluorescent, the performance and price is going to have to get a little bit better before you jump in on those applications. So again, do your homework, do a little math, do a little testing, and you'll find a good answer for your application.
Great. Mark, our last question that came through was that they've heard that LEDs don't work well with existing dimming. Why is that? And will that change at some point?
That is a big issue, especially for the residential market. The existing dimmers are usually very simple dimmers meant to work with incandescent, and a lot of times they were also very inexpensive, real cheap dimmers, so they weren't good dimmers to begin with. I've found just at home, I've installed some LED downlights in my kitchen, and I tested them out, and they work really well. One of the issues with existing dimmers is a lot of them just weren't rated for the low load that LEDs have. So you could put LEDs on a circuit that was just never designed. It was never even conceived of that you would have that low of a load on that circuit. So that's one of the issues with existing dimmers, is that minimum load. The other is the different ways that dimmers dim light bulbs. There's some good dimmers that are out there. I know Lutron comes to mind. They make one that's commonly made, and it's designed to work well with incandescent, CFL, and LED. So it's like an all-purpose dimmer. And other companies will be coming out with that as well.
Great, thank you, Mark. And before we close out here, I wanted to mention again, thank you for joining us, and we will be following up with materials, but we do have on this slide our upcoming lighting webinars and seminars. If you'd like to join us, Mark Whitney teaches the Better Lighting Lower Cost Workshop, and we have, he also teaches an Intro to Efficient Lighting and Controls webinar scheduled for May 15th, and then we have some guest speakers that join us at the Portland Lights Trade Show, and that's a great opportunity for you to learn on different aspects of lighting, as well as see visual props from all the vendors and distributors that are invited. It was a great show last year. It was the first year we introduced it, and we're bringing it back again this year, and that's June 5th, and you can register for that now. And then we bring back Stan Wallerchek in September for the Human-Centric Lighting Seminar. As I understand, that's a huge topic in the lighting industry right now, and how it impacts us as humans. And then he'll also stick around for an additional day to do outdoor lighting for customers whose main focus is the outdoor lighting. So again, visit our website to register for more, and thank you again for joining us. We will stay online a little bit longer in case you have further questions or want to send more information for us. Let me know. Thanks you again, everyone.